Hi there and welcome to Penguin Learning. In this National 4 Maths lesson, we are going to continue doing practice questions for the National 4 Maths exam, but this time we are going to have a look at questions that involve us using a calculator. This means now that the sums that we want to calculate in order to solve problems or get a final answer would be a little bit too tricky to just do by ourselves or without using a calculator, so the calculator is going to give us practice using more complex sums. In this lesson we will go over 4 questions, and what I recommend you do is try the questions first by yourself after I've laid out the question for you, and then afterwards you can follow along and check if you got the right answer. So let's get started.
Ooh la la!
Okay, so let's have a look at question 1. We are told that Stephen is buying new kitchen cabinets, and in particular he buys 3 base cabinets of width 50cm, 2 wall cabinets of width 30cm, and 1 drawer cabinet of width 80cm, and we've been asked to calculate the total cost of his kitchen cabinets. Now we can see here we're given a table, and in the table we're presented information on the price of certain kitchen cabinets and specific price for the different widths of each type of these cabinets. So a question like this challenges our ability to read a table like this and gather the correct information from it. So the way I'm going to do this is go through each 3 of these things and highlight them where they are in the table. So let's begin by looking at the first one. We are told that we have 3 base cabinets of width 50cm. Now we can see here's the base cabinets, and for 50cm it's going to be this value right here, so that's £66. Next we have wall cabinets of width 30cm. So again here we have wall, and here is the width of 30cm, so that means it's going to be this value here of £39. So let's just highlight that. And then finally we are told that he has 1 drawer cabinet of a width of 80cm. So again, let's find drawer. We have it here, and then for 80cm we're going to go along to this column, and we can see that's 179. Now what I'm going to do right next to each of the colours that I've highlighted is write how many Stephen bought of each. So we're told for the base cabinets he bought 3, for the walled cabinets he bought 2, and for the drawer he only bought 1 of them. So now we can see which item that he bought and the price of it, but then also the frequency or the amount of each item that he bought. So now all we have to do is just add up the cost of everything. So first of all we have 3 multiplied by £66, and because this is a calculator paper we can just put this into a calculator and we get an answer of £198. And that was for the base cabinets. So now let's have a look at the wall cabinets. For that it would be 2 multiplied by £39, and that gives us an answer of £78. And then finally for the drawer cabinet it's just going to simply be 1 multiplied by the £179, and that's just going to give us the answer of 179. Now that's the cost of each type of drawer and the frequency of how often Stephen bought them. So now all we have to do is add each of these values together, and that will give us the total cost. So if we add 198 to 78 to 179, that will give us a total cost of £455. So that's how much money Stephen spent on buying kitchen cabinets. Okay, so moving on to question 2. The question tells us that Maggie bought a garden shed, and the dimensions for one side of the shed are shown in the diagram below. So here we have that one side of the shed right here. And the question asks us to calculate the length of ST. So that would be this side of the shed here. So looking at what the shape is initially, we can see that it has 4 sides, which means the shape's a quadrilateral. But we can see here that we're told that these angles are right angles indicated by these little squares down here. So that means we have 90-degree angles down here. So that must mean that, imagine if we drew a line from S and it was parallel with the line VU at the bottom. So a line that's parallel from here to here we can see that that would divide the shape into two different shapes, and that would be two shapes that we are more familiar with. And doing that, it's clear that now we have a rectangle, and sitting on top of that we have a triangle. But in particular, because we know that this in here is a right angle, and so is that, and also the red line, we draw that so it's parallel with VU so that it forms a rectangle. That must mean that the angle in here as well is also a right angle, making this triangle a right angled triangle. And because we have right angles down here, and this length is 120, then this must also be 120 up here as well. And one other thing that we can do is figure out the difference between this point and this point. Because we know this length is 230 and this length is 190, that must mean that from here to here would be the difference between 230 and 190. So if we do that, we take the difference between 230 and 190, that gives us a length of 40 centimetres for this little distance right in here. And then now what we have is, we have this right angle triangle up the top, and now we know the length of two sides. So we know this side is 120 centimetres and this side is 40 centimetres. And now all we're left with is an unknown side which we want to calculate, ST. And if we have a right angled triangle and we know two sides and want to calculate one other side, then we can use Pythagoras' theorem. So let's do that right now. To begin, we always name the hypotenuse, which is the side opposite the right angle, A, and then the other two sides, B and C. And Pythagoras' theorem says that A squared is equal to B squared plus C squared for any right angled triangle. Now let's put in the values for each of these. So A, I'm just going to call ST. So ST squared is equal to, B is 120, so B squared is 120 squared, plus 40 squared for C squared. So 120 squared will give us an answer of 14,400, and 40 squared will give us an answer of 1,600. And if we add both of them together, so 14,400 plus 1,600 will give us an answer of 16,000. And then now that was ST squared, what we have to do is take the square root of that if we want to just get the length ST. So that would be the square root of 16,000. And if we put this into a calculator, we should get an answer roughly equal to 126.5, and don't forget our units, we are working in centimetres. So that means that for the top of our shape, or it's like the top slope of the shed, we now know that distance is going to be equal to 126.5 centimetres. And again, we did this by using Pythagoras, but first of all, the key thing is to know how to divide up a shape like this, and we can recognise, right, it's quite a complex shape at first, but if we look at it, we can divide it into both a rectangle and a right angled triangle. We can then calculate the difference between the two vertical sides, and that gives us this length of 40 centimetres. And then because we have two sides that are known, one side that's unknown, use Pythagoras' theorem, and then we can get this answer right here. Okay, so question 3, we are told that, well, for part A, that we have to complete the table for y is equal to 2x minus 1. So we know that an equation like this tells us that it's going to be a straight line, because the relationship between y and x is linear, and it also takes up the form y is equal to mx plus c, which is the general equation of a straight line, so that's good. And now for part B, we're asked to use the table and then draw the line of y is equal to 2x minus 1 on the grid below. So let's just focus on part A at the moment and focus on completing this table that we have here. So we're told that we have a straight line, and the equation for this straight line is y is equal to 2x minus 1. And this table asks us to fill out the values for y when it gives us certain values for x. So we have when x is minus 1, x is 1, and x is 3. And to get the y values, what we have to do is sub in each of these values for x into our equation, and then that will give us a value for y. So let's do that right now. So when x is minus 1, y is equal to 2 minus 1 minus 1. And then when we have that in the brackets, that just means multiply. So we're going to have 2 times minus 1 is minus 2, minus 1, and that means y is minus 3. So when x is minus 1, y is minus 3. Next up, when x is 1, y is equal to 2 brackets 1 minus 1, and 2 times 1 is 2, so we have 2 minus 1, and then that just gives an answer of 1. So when x is 1, y is also 1. And then finally, when x is 3, we will have y is equal to 2 brackets 3 minus 1. That means we have 2 times 3 is 6 minus 1, so that means y is 5. So therefore, when x is 3, y is 5, and that's our table now complete. Okay, so now for part B, we've been asked to use the table to draw the line on this xy diagram. And how we do that is, well, basically what we have now is values for x and y. So when x is equal to something, y is equal to something. And what that means is we essentially have 3 coordinates that lie on the line. So our first coordinate is going to be minus 1, minus 3. Our second coordinate is going to be 1, 1. And our second coordinate is going to be 3, 5. Because we know that for coordinates we always have the x value first and then the y. And that's exactly what this table provides us. It has x and y values that are paired up with one another. So now all I'm going to do is just plot these points on our diagram. So first of all, we have minus 1, minus 3. So that's minus 1 in the x, so that's that point here. Our next point is 1, 1. So that's 1 in the x and 1 in the y. And the final point is 3, 5. So that's 3 in the x and 5 in the y, so right up here. So now we have 3 points that lie on the line. All we can do now is draw a straight line and connect them all together, just like that. And then that means now we have drawn the line of y is equal to 2x minus 1. Now we can sort of check to see if this answer is correct by using the general equation of any straight line. We know that the equation is y is equal to mx plus c, and we know that the gradient is equal to m, and the y-intercept, or the point in which the line crosses the y-axis, is equal to c. Now for our line, we can see that m is equal to 2 because we have the y is equal to 2x, so that means m is 2. And we can also see that c is equal to minus 1, so that's the point in which the line should cross the y-axis. And we can definitely see here that this is the point in which the line crosses the y-axis, and we can see it does so when y is minus 1, so we know that this is correct for c. And we can also see that for when the gradient is 2, well, if the gradient is 2, that means it must be positive, so it's sloping in the right direction. But to check that it's equal to 2, we can see that the gradient is always equal to the vertical distance divided by the horizontal distance between 2 points. And we can see that's definitely the case as well, because to get to the line we have to go 1 across but 2 up, 1 across but 2 up, 1 across but 2 up, and so on. And that means that the vertical distance is double the horizontal, so that means that the gradient is going to be 2 divided by 1, which gives us a gradient of 2. So that just confirms that the line that we drew is indeed correct. So this fourth and final question of this lesson is going to test our ability on solving equations and also factorising. So let's look at 4.8 first. We're asked to solve algebraically the equation 6, and then inside brackets we have 2x minus 3, and then on the other side we're told that's all equal to 42. Okay, so there's multiple ways we can go about solving this, but essentially what we want to do is the end goal is to have something that looks like this. X is equal to some number. So that's what we want to do. We want to rearrange it so we can have x by itself. And now the first thing that I'm going to do, we can see here that x is already inside this bracket here. And because the 6 is outside the bracket, that means we can treat that differently from everything inside. And when we have the 6 in that position, it's almost like saying 6 times, or like 6 multiplying what's inside that bracket. So what I'm going to do is take this 6 over to the other side, and because it's multiplying on this side, when we move it over, it's going to be dividing by. So that means we're going to have 2x minus 3 is equal to 42 divided by 6. So all I've did there is take the 6 over to the other side, and because it's multiplying on this side, it's going to divide when we take it over. And we can just simply say now that 42 divided by 6 is equal to 7, because we know that 6 times 7 is 42, so 42 divided by 6 must be equal to 7. So that means already we are just left with 2x minus 3 is equal to 7. And then now here we can see we have the 2x, so what we now want to do is get rid of this minus 3 in some fashion, and we do that the same again by taking it over to the other side. And because it's negative or minus on that side, when we take it over, it's going to become plus. So that means it's going to be 2x is equal to 7 plus the 3. And that now means we can say that 2x is equal to 10. And if 2x is equal to 10, well now all we have to do is get rid of the 2. And because 2x is the same as 2 times x, we can take the 2 over, and instead of multiplying on one side, it's going to be divided by on the other side. So if we have x is equal to 10 divided by 2, that means that our final answer is just x is equal to 5. And now for part B, we were asked to factorise this expression that was 12t minus 9u. And now the first thing that we always look for when we go to factorise is a common factor between terms. So a common factor between 12t and a common factor between 9u. Now we can see that both of these terms are made up of both numbers and variables. So what we have to do is look for common factors between both of them. So let's have a look at the numbers first. To do this, we have to think of numbers, the highest number that would go into both 9 and 12. And the first thing that I can think of is 3 could perhaps go into both, because we know that 3 times 4 is 12, and also 3 times 3 is 9. So that means we've established 3 as the highest common factor. So that means we put that outside the brackets, and then we think of what the terms are going to be inside the bracket. And how we do that is divide each of the terms by whatever the highest common factor was. So it would be 12t divided by 3, and that would give us 4t. And then we would do 9u divided by 3, and that would just give us 3u. And we can check this to see if it was correct. So it's like saying 3 times 4t is 12t, and 3 times 3u is 9u. So that's us done. And then, as I said as well, I like to normally do the variable factorising and the number factorising separate. But because t and u are totally different variables, then there's no common factor between these variables. So that just means that this, what we have here, is our final answer, and that can't be factorised any further. So I hope going over these calculator practice questions for the National 4 exam has been helpful to you. And if that's been the case, be sure to give the video a thumbs up. But if you have any questions on any of the 4 ones that we touched on here, comment down below and I'll try and help you out. And if you'd like to see more content like this, be sure to subscribe to our channel or head over to our website at penguin-learning.com. As always, thanks for watching, and I'll see you in the next video.